Okay, welcome back from spring break. I hope everybody stayed healthy and was able to have some time relaxing. I know this is a really stressful time, but I really do want to work with you to try to make this semester work. So don't hesitate to reach out and let me know what you need. It's tough to transition to an online class in the middle of the semester, but we will make the best of it. Okay. So what we're looking at today is section, would help if I wrote down the right section 4.2, which is translations of the sine and cosine graphs. Okay, so what I want to do is I want to graph two different functions. I want to first of all graph y equals sine of x, and then I want to graph y equals 2 plus sine of x. Okay, and I'm actually going to graph them on the same set of axes so that I can sort of compare their shapes. Okay. So what I'm going to do is I'm going to come up with a nice table of values here. I'm going to leave some space because I'm going to add on to this table of values in a little bit. So if you're taking notes, leave some space here for a third column. But I'm going to have x and then sine of x. And what we saw before the break was that it made sense to plug in quadrantal angles going through one complete revolution around the unit circle. So 0 pi over 2 pi, 3 pi over 2, and then 2 pi. Remember, the sine wave is the one that starts at the origin, so it starts at a middle value of 0, goes up to a high point of 1, back down to 0, down to -1, and back to 0. So I'm going to mark off pi over 2, pi, 3 pi over 2, 2 pi. I'm going to mark off my high values of 1, my low values of -1, and now I'm just going to plot these points. So when my angle is 0, sine is 0. When my angle is pi over 2, sine is 1. At pi, we're at 0. At 3 pi over 2, -1. And at 2 pi, we're back to 0. And so then I can connect this with a nice smooth curve. And don't stop there. Remember, this goes on forever. So I do want to see the arrows that indicate that the pattern continues. Okay. All right, so that's y equals sine of x. And just to remind us, with y equals sine of x, the period is 2 pi. That's the length of the interval that it takes for it to do its thing one time. And the amplitude is 1. Okay. All right, so now I want to take a look at y equals 2 plus sine x. And I'm realizing I didn't write that period and amplitude at exactly the greatest spot, so I'm just going to erase that information here because I wanted to add a third column here. I want to take a look at 2 plus sine of x. So that's the function that I'm going to graph, and I'm going to graph it on the same pair of axes. I'm just going to graph it in red. When I'm graphing it, x is still my input. The y values in this column will be the y values that I'm plotting. So this middle column is just sort of a helper column because that's how I actually calculate this. I take x, I plug it into sine, and then I add 2. So 0 plus 2 is 2, 1 plus 2 is 3, 0 plus 2 is 2, -1 plus 2 is 1, and 0 plus 2 is 2. So we've literally added 2 to each of the y values. And what that's going to do is that's just going to shift the graph up by 2 units. So I can see I have 1 still, but that's now my low value. I've got 2 is the new middle value and 3 is the new high value. I find it helpful, although this isn't absolutely necessary, to just draw in dotted lines at those heights. If you have graph paper, that's not necessary. This is like the grid lines that you would have. If you do this, make sure they're dotted lines, not solid lines, because solid lines would be considered part of the curve. But then I can plot my points. 0, 2, pi over 2, 3, pi, 2. And notice, it's basically the same pattern. Middle, high, middle, low, middle. I just have a new high, middle, and low value. So we really have literally just taken this graph and shifted it 2 units up. When we did that, that didn't change the period. It's still equal to 2 pi, and it didn't change the amplitude. Because remember, the amplitude isn't how high is the highest point. The amplitude is the vertical distance between your middle value and your high value, so the amplitude is still 1. What happened is we did a vertical shift. We moved things up 2 units. Okay, now let's try another one. I'm going to get you started on this one, but then I'm going to have you pause the video and see if you can work it out yourself, and then turn the video back on to check your answer. So let's start by just graphing y equals cosine of x. So I would create a table of values for x and cosine of x. Some of you may be at the point where you can graph cosine of x without creating the table of values. Totally fine, just go for the graph. The table of values is just if it helps you in getting to that correct graph. And as always, we want to just go through the quadrantal angles corresponding to 1 revolution around the unit circle. Okay, so pause your video, take a moment to fill in this table of values if you need it. If you don't need it, just go right to the graph me cosine, and then turn the video back on. I'm going to pause so I can write the answer on the board so it'll be here when you come back.